Chair of the one-time specialized academic council, Doctor of Technical Science, Professor Head of the Department of Electric Transport and Diesel Locomotive Engineering Boris Lyubarsky. Dear members of the one-time specialized academic council DF 64.050.264, pursuant to order number 221 OD of the National Technical University Kharkiv Polytechnic Institute, dated 1st June 2026, our time specialized academic council was established with 5 members, namely Chair of one-time specialized academic council Boris Lyubarsky, Doctor of Technical Science, Professor, Head of Department of Electric Transport and Diesel Locomotive Engineering, National Technical University, Kharkiv Polytechnic Institute. Reviewer Dmitro Gapon, Doctor of Technical Science, Associate Professor, Head of the Department of the Automation and Cybersecurity of the Power System, National Technical University, Kharkiv Polytechnic Institute. Reviewer Tatiana Kunchenko, Candidate of Technical Science, Associate Professor of the Department of Automatic Electromechanical System, National Technical University, Kharkiv Polytechnic Institute. Official opponent Alexei Chorny, Doctor of Technical Science, Professor of the Department of Automatic Control System and Electric Drive, Kremenchuk Mikhail Ostrogradsky National University. Official opponent Valery Tityuk, Doctor of Technical Science, Professor of the Department of Electromechanics, Kryvyi Rih National University. All members of the council and the applicant's academic supervisor are present. Therefore, the meeting of one-time specialized academic council has a quorum and is hereby declared open. The dissertation defense will be held online via the Microsoft 365 platform to reduce network load and ensure the best possible sound quality. Tatiana Yurievna Kunchenko will keep her camera off during the defense. Does every agree? Please vote by result the hand. All are in favor. Thank you. The decision is adopted unanimously. They agree with the applicant the presentation of the main provision of the dissertation, the answers to questions and participation in the academic discussion will be English. Today, answer is the follows. Difference of the dissertation by Hань, a postgraduate student of the Department of the Automatic Electromechanical System at the National Technical University, Kharkiv Polytechnic Institute, in implementation of the intelligence control system to improve the safety of the electric vehicles by means of the electric drives. The dissertation is submit for the degree of Doctor of Philosophy in the field of knowledge 40 electric engineering specialty 141 electric energetics, electric engineering, and electromechanics. Biographical information about the applicant. Liu Hань was born on 9 November 1979 and the citizen of the People Public of China. In 2005, he graduated from Zhanjiang University with a degree in English, engineering, and electrical applications. His foreign educational qualification has been recognized in Ukraine, the corresponding to second master's level of hard education. Since 2022 has been awarded in postgraduate studies at the National Technical University, Kharkiv Polytechnic Institute, specializing in 141 electric energetics, electric engineering, and electromechanics at the Department of Automatic Electromechanical System. The dissertation was complete at the Department of Automatic Electromechanical System of the National Technical University, Kharkiv Polytechnic Institute, Ministry of Education and Science of Ukraine. The dissertation has passed an academic plagiarism check. Academic supervisor Dmitro Pshenichnikov, candidate of technical science, as associate professor of the Department of the Automatic Electromechanical System, National Technical University, Kharkiv Polytechnic Institute. Bogdan Vorobyov, Doctor of Philosophy, Vice Rector for Research, Development, Management, and International Relations, Donbass State Engineering Academy. The dissertation has been checking for academic plagiarism. The applicant submits the following document to the one-time specialized academic council in accordance with the regulations on the establishment of one-time specialized academic council, the difference procedure, and the award of the degree of Doctor of Philosophy and into KPI, in well as procedure for awarding the degree Doctor of Philosophy approved by resolution number 44, the Cabinet of Ministry of Ukraine, dated 12 January 2022. An application for attestation, a certificate copy of the educational document, the certificate copy of the master diploma and document confirming recognition of the foreign educational qualification in Ukraine, an extract form order on admission on postgraduate study, an academic transcript confirming completion of the educational and research promote, the academic supervisor conclusions, the conclusion on scientific novelty and theoretical and practical significance of dissertation result, the dissertation in printed and electronic forms, certificate copies of academic publications on The dissertation topic, a report on checking the dissertation manuscript for academic plagiarism, information on the establishment of the one-time council and enters into the information system of national energy for higher educational qualification. All documents comply with the established requirements. The dissertation and relate meetings the conclusion on the scientific novelty and the theoretical and practical significance of the dissertation results, the certificate from Ukraine states, the review reports, and the official openness reports being published on the university official website. The floor is now given to the applicant to present the main provisions of the dissertation. The time limit is up to 20 minutes. Please. Лехань.
Okay. I'm Liu Han. No.
Identification.
Good morning, respected chair and member of the suspect. Good morning, respected chair, members of the specialized academic council. My name is Liu Han. I present my designation. Implement of intelligent control system to improve the safety of electric vehicle by means of electric drivers. Completed at National Technical University, Kharkiv Polytechnic Institute under supervision of Dmitry Pushnikov and Bogdan Volobyov. The rapid growth of electrical transport makes operational safety increasingly important. One critical problem is the loss of wheel load adhesion, which reduces vehicle stability and controllability. Electrical driver provides fast and accurate torque control, creating opportunity for intelligent system and detect and limit wheel sleep. Wheel sleep occurs when the tractive force exceeds the variable wheel load adhesion. It is especially dangerous during acceleration on wet, icy, or loose surface. Existing ABS and ASR systems improve safety, but generally use fixed threshold and response after slap begins. Changing load and vehicle parameters therefore require more adaptive control methods. The aim of dissertation to improve electric vehicle operational safety by developing and studying a traction electrical driver control system for developing and preventing wheel sleep, taking into account static and dynamic characteristics of industrial electric driver. and the specific features of the real-world interaction. The research task covered four main stages: analysis of electric transport and existing anti-slip system, selection of transmission, motor, and onboard energy source, development and simulation of the induction driver and vehicle model in normal and slip models, and synthesis and computer verification of the narrow network-based slip prevention system. The object of research is the process of improving electric vehicle operational safety by means of traction electric driver control. The subject is transient electrical mechanical process in an induction driver with a well-slip dictation and prevention system based on narrow network controller. The global expansion of electric vehicle is supported by environmental requirements, charging infrastructure, and advance in battery power electrical. The growth increase the importance of improving active safe system, specifically for electric traction driver. Modern vehicles use ABS to prevent wheel locking during braking and ASR to limit excessive wheel slip during acceleration. Both systems use wheel speed information and influence braking force or driver torque to maintain adhesion and stability. Their limitations include activation after sleep begins depends on slashers. Depend on predefined slashers and sensitivity to change load condition and vehicle parameters. These factors can be delay or reduce the quality of control in non-linear and time-varying operating model. The research graph is therefore the need for an adaptive system that can detect wheel speed mismatch and from appropriate torque correction on the changing adhesion condition. The task motivated the use of intelligent control methods. The scientific results include substantiated methodological approach to studying the traction driver as part of complete vehicle powertrain, a mathematical and computer model of electric vehicle with induction traction driver, a method for developing wheel slip by comparing vehicle linear speed with driving wheel angular speed, and intelligent slip prevention system using a normal L2 controller. The main contribution is integrated study of power supply, converter, induction motor, control system, transmission, differential, vehicle motion, and external loads. The model supports both normal and well-sleep models, while the control forms its action from speed mismatch and reduce the uncontrolled separation of the sleepy well. The selected full electric vehicle structure include a charger, lithium-ion battery, power converter, induction traction motor, mechanical transmission, and differential. This configuration was used to as basis for mathematical and computer models. Transmission ratio and torque characteristic was calculated to provide the required traction during acceleration and low-speed operation. The analysis confirmed feasibility of using a gearbox in investigate induction electric driver. A squirrel cage induction motor L180M2 was selected after comparing alternative motor types. Its rated power is 13 kilowatts. Rated speed is 2,935 revolutions per minute. Rated torque is 95 Newton meters, and overload capacity is 2.2 per unit. The motor also checked for power, overload capability, and overheating. The electric vehicle model was developed in MATLAB Simulink. It combines the battery, power converter, induction motor, and its control system, mechanical transmission, differential, vehicle motion, and external load components. It supports simulation of both normal motion and well sleep. The mechanical model describes the vehicle motion and wheel dynamic. It's considered tractive effort, loading response, aerodynamic drag, gravitational force, the mechanical differential, and the relationship between driving wheel angular speed and vehicle linear speed. The load model calculation, the resistance force, normal reaction at the wheel, and the transmission ratio for the select gear. This provides the mechanical load required to investigate normal traction and reduce the adhesion condition. The complete computer model integrates the electrical, mechanical, and control subsystem. It was used to analyze transient process and to test pro- proposed sleep dictation and prevention approach on the repeatable simulation condition. Classical controller, particularly PID controller, are simple and effective under stable condition. However, where load interaction is non-linear and changing with adhesion, load, and speed. These limits fix the parameter controller and motivate the investigation of adaptive nano approach. Nano network can approximately non-linearly dynamic relationship from training data. In this work, they are used to identify the control plant and support torque correction according to wheel speed mismatch. The purpose is to reduce the uncontrolled acceleration of sleepy wheel as operating condition change. The select normal L2 structure presents non-linearly plant in a form that allows the control input to be calculated from previously inputs and outputs and the desired response. The controller used the previously identified plant model and was implemented with the normal L2 block from the MATLAB Nano Network toolbox. In the generalized control structure, the plant model operates on the only error and minimize the speed mismatch. The nano control process the reference and the feedback signal and change the track driver command. In this way, excessively acceleration of the wheel in a low-headage surface is limited. Training data was generated with development computer model. The settings shown on this slide include the natural network structure, signal limits, number of epochs, time samples, and the number of training samples. These parameters were used to identify the plant model required by the normal L2 controller. The plant identification network was trained for 500 epochs. The training process determined the main control parameters for a linearized reference model. The identification result shows that the network reproduced the model response with a small error. The best train of performance are achieved at epoch 21. The regression coefficient was R equaled 0.98939, corresponding to approximately 1% signal error for the identified plant model. Despite the linearization, the output followed the input signal very closely. The simulation sequence includes startup without sleep, startup with one wheel on reduced adhesion surface, and operation the nano controller. Operation of the nano controller when the adhesion change during acceleration. The load slope was zero, and the result were exceed from motor torque, wheel speed, vehicle speed, and their mismatch. On the full wheel traction, the motor reached the set speed approximately about 6 seconds. 6 seconds. And the torque followed the pattern reference with a nominal value of 95 Newton meter. During startup without sleep, the speed and the torque of two driving wheels were equal, as expected for a differential torque distributions. The next simulation reproduced sleep from startup. The adhesion coefficient was 0.95 for one wheel and 0.1 for the other. The speed of the sleepy wheel reached about 150 radians per second, while the other wheel was about 5 radians per second. The model considered longitudinal motion and does not include lateral skid. The narrow control test began in second gear with the adhesion coefficient of 0.95 at 2 seconds. One wheel consolidated a surface with a coefficient of 0.1. The controller reduced the torque in response to speed error and prevented uncontrolled wheel acceleration. On the non-linear model, the remain speed mismatch was 0.07 inverse second, or about 1%. Result analysis. The simulation confirmed the operability of the proposed system. A functional traction control scheme and a normal L2 based on computer model was developed. The plant model and the control were trained. And the celebration of celebration with subscreens one wheel sleep was stimulated. The controller reduced the wheel speed mismatch and prevented successive acceleration on the investigated condition. The developed model and the simulation procedure can be used to study, design, and improve electric vehicle traction driver with sleep prevention function. The normal L2 system can be served as basic for further control algorithm development. The results have also been implemented in in the education process at NTU Kharkiv Polytechnic Institute. In conclusion, the dissertation developed integrate mathematical and computer model of electrical vehicle with induction traction driver, while sleep detection method based on speed comparison and intelligent normal L2 control system. Computer simulation of normal motion and reduced addition model showed that the controller limits uncontrolled acceleration of sleepy wheel. These results support further development of intelligent safety function for electric drivers. Thank you attention. I'm ready to answer your question. Thank you.
Thank you for your presentation. The next stage of the difference is questions. Let us begin with the reviewers. The floor is given to reviewers, Doctor of Technical Science, Associate Professor, Heart of Department of Automation and Cybersecurity of Power System at NTU KPI, Dmitro Anatolyevich Gapon.
Thank you. I have some questions, and the first question is, Luhan, can you tell me what indicator was used in the dissertation to assess the improvement in driving safety? And under what conditions was the proposed system tested?
Okay, in this study, the main indicator was a mismatch between the electrical vehicle speed and the driving wheel speed. The system was tested during normal acceleration and when the adhesion of one wheel to load decreased sharply under action of the narrow controller. The speed mismatch error decreased to about 1%, and uncontrolled wheel acceleration was stopped. Simultaneously, slipping of several wheels and motion on non-uniform load surface were not investigated separately.
Okay, thank you. Next question. How was the training data set for NARMA L2 controller was generated, and how was the quality of training assessed?
Okay, the training data were generated using the developed computer model for normal and well sleep models. The training used 10,000 simulation samples, 500 training apples, and 9 hidden layer narrows. The best result was obtained at APA 21, and regression coefficient was 0.98939. Especially detailed analysis, the risk of overfitting was not performed.
Okay, thank you. Okay, next question. What role could be a proposed neutral control play in the overall electric vehicle control system?
The controller should operate within the traction torque control loop and generate corrective action when wheel slip detected. In a real system, it should interact with the supervision vehicle controller, the driver's command and the stability controller system. Detailed interaction with ABS and ESP was not simulated in this study.
Okay, thank you. I have no further questions.
Dmitry Anatolyevich, are satisfied with the applicant's answers?
Yes, I am fully satisfied.
Thank you, Dmitry Anatolyevich. The floor is now given to the reviewer for her questions. Candidate of Technical Science, Associate Professor of the Department of the Automatic Electric Mechanical System at NTU KPI, Tatiana Yurievna Kuchenko.
Okay, thank you. Luhan, tell me please, how is the electric vehicles line of speed estimated in the system, and how in the estimation or reduced?
Okay.
This is the one question.
Okay, linear speed is estimated by integrating the linear speed estimated by integrated oscillational signal during steady motion. The accurate error is reduced through periodical correction using the speed of a wheel that not sleeping. The effect of sensor noise and time release were not investigated separately in this study.
Okay, the next question, please. Which parameters of the mechanical models directly affect the operation of the while slip prevention system?
Okay. The most important parameter are vehicle mass, vehicle radius, and motor of initial, transmission ratio, resistance force, and the adhesion coefficient. Those parameters determine the acceleration dynamic and magnitude of the speed mismatch by which the system detects wheel slip.
Thank you. And the third question, tell me please, how can change in induction motor parameters caused by heating affect the operation of the while slip prevention system?
Okay. Heating changes the stator and rotor resistance, which may affect electromagnetic torque and the driver response speed. Temperature depend on parameter change were not considered separately in the model. In a real system, they should be taken into account using parameter observe or adaptive correction.
Thank you. I have no question.
Thank you, Tatiana Yurievna. Will the opponent, Alexey Petrovich Chorny, ask questions, or will he state all his comments in the written review?
No, all questions included in my report. I have 2 additional questions.
Will the opponent, Valery Konstantinovich Tetyuk, ask question, or will he state all his comments in the written review?
My comments and questions are set out in the report, so I have no any additional questions.
Do any of the present have questions for the applicant? If there are no questions, please allow me ask questions to question. Question one. Why was an induction traction motors select for this study?
Induction motor has simple and reliable design, does not require parameter magnets, and operate well with modern frequency converter. The select 30 kilowatt L1 ATM2 motor meets calculated traction and dynamic requirements of the electrical vehicle model.
Okay, question two. What is the main limitation of the complete study and what should be next stage of the work?
The main limitation is that the system was verified only by computer simulation. The next stage should include test bench experiment, real-time verification, and subsequent test of the system on a real vehicle.
Thank you. I propose to close the discussion. Are there any other propose? No. Propose? No. The floor is given to the question supervisor, candidate of technical science, associate professor of the Department of the Automatic Electromechanical System at NTU KPI Dmitro Alexey Pshenichnikov.
Thank you. Dear members of the council, during his postgraduate studies, Luhan demonstrated perseverance, independence, and the ability to work systematically with academic information. He consistently mastered the methods for modeling electromechanical systems, fulfilled his individual study plan responsibly, and took recommendations into account when preparing the dissertation. I consider him prepared for independent research. Thank you.
Are there any questions for the scientific supervisor? No. The floor is given to the scientific supervisor, doctor of philosophy, PhD, vice rector for research, development, management, and integration realized at Donbass Stage Engineering Academy, host Bogdan Vitalyevich Vorobyov.
Thank you, dear colleagues. In course of this work, Luhan demonstrated responsible attitude to research, an ability to analyze simulation results, and ability to discuss the obtained data with sound agreements. He participated in preparing academic publications and presentations, his results, work appropriately with co-authors, and completed the educational research program. I support the dissertation, and I believe that Luhan deserves to be awarded degree of Doctor of Philosophy. Thank you.
Thank you. Are there any questions? The academic supervisor? There are none. Thank you. The floor is given to the official opponent, Doctor of Technical Science, Professor of the Department of the Automatic Control System and Electric Drives at Kremenchuk Mikhail Ostrogradsky National University, Alexey Petrovich Chorny, please.
Thank you. Dear members of the Council, Liu Huan dissertation addressed the relevant scientific and employment task of improving electric vehicles safety through traction electric drive control. The auto developed interconnected mathematical and computer models of an electric vehicle improved the wheel slip detection method and investigated the normal L2 neural network controller. The results have been published in 11 work and no violation of academic integrity were found. At the same time, the report contains the following comments. 1. Some statements of scientific knowledge in the dissertation are excessively detailed and partly procedural. Involve the be addressable to combine the statements, concerning the methodological approach and mathematical and computer model, and not to present simulation-based confirmation of the system operability as an independent element of scientific knowledge. 2. The choose the normal L2 neural network controller is insufficiently substantiated. It's the advantages our other controls should have been demonstrated more clearly, and the critical the selecting and the structure and training parameters should they have been provided. 3. From the standpoint of particular implementation of the wheel slip detection method, based on comparing the vehicle's linear speed with the angular speeds of the gearing wheels required the explanation. The dissertation should have considered in great details how the electric vehicle linear speed would be determined in the real system and how sensor error, measurement delay, signal filtering, and noise in the feedback channels would affect the result. 4. The mathematical model of wheel-road interaction should have been substantiated in the great detail. The study considered reduced adhesion conditional and wheel slip models. However, in the should also have demonstrated the sensitivity of the result to changes in the adhesion coefficient, slip, the Schulz road parameters, and scenarios in which several during will slip simultaneously. 5. The operability on the proposed system with verified mainly by computer simulation in MATLAB Simulink. This confirms the correctness of the model-based study, but test bench of experimental trials would have strengthened the practical value of the work and made it possible to assess the results could be transferred to real electric vehicles. 6. The practical recommendation for implementing in the neural work system require further specification. The requirement of the computational resource and the real-time operation should have been defined, and the limitation on traction, electric drive during transient models should have been taken into account. These comments are advisory and do not diminish the value of the work. The dissertation is a completed academic work, complies with the requirement of the paragraph 6.9 of the procedure for awarding the degrees of Doctor of Philosophy, and its author deserves to be awarded the degree of Doctor of Philosophy in specialty 141 electrical engineering, electrical energetic, electrical engineering, and electrical electromechanics. Thank you.
Thank you. The floor is given to the applicant to respond to the comment.
Thank you. That's my answer. Answer one, I graded the comment. The methodological approach and the mathematical and computer model contribute a single intelligent integrated result, while computer verification characteristics, reliability, and operability rather than several scientific novelty. In consolidating thought, the novelty comprises the model, the well-sleep dictation method, and the development of narrow networks control. Answer 2. Norma L2 was selected because it is designed to control non-linear dynamic plans and use a narrow network model of their behavior. This corresponds to the non-linear nature of real-load interaction and valuable operating model of the traction electric driver. A direct quantitative comparison with PID fuzzy logical and the other narrow network controller was not performed in my study. Answer 3. In a particular implementation, where angular speed can be measured with encoder, while linear speed can be estimated by integrating an accelerometer signal with periodical correction. Stance error, noise, flickering, and delay was not modeled separately, and therefore their inference requires further investigation. Answer 4. The study used a prescribed change in the adhesion coefficient of overdriving adhesion coefficient of one driving wheel from 0.95 to 0.1. This is sufficient to verify the basic operability of a controller in the selected scenario. but not for complete sensitive analysis. Different load conditions simultaneously sleep of several simultaneously sleep of several whales should be examined through extended simulation. Answer 5. Agreed. All the present results were obtained by computer simulation. No test bench or full score test were performed. Experimental verification and transfer of algorithm to a real electrical vehicle are therefore the next stage of the work. Answer 6. Requirement for Pacific hardware platform, computing resource, delays, and stable real-time operation was not assessed in detail. Before particular implement, the algorithm must be profiled. Sampling rate select, real-time operating verified, and the limitation of the convert and the motor taken into the account. Thank you.
Thank you. Alexey Petrovich, are satisfied with the applicant's answers?
Yes, I am satisfied.
The floor is given to the official opponents, Doctor of Technical Science, Professor of the Department of Electromechanics at Kryvyi Rih National University, Kryvyi Rih, Valery Konstantinovich Tityuk. Please. Microphone, please.
Sorry, it's my fault. Dear members of the Council, Luhan's dissertation is a completed study that addresses the relevant task of detecting and preventing electric vehicle wheel slip by means of the traction electric drive. The work has a logical structure and contains substantiated models of the electromechanical system and the results of a computer-based study of the neural network controller. The main provisions have been published and no violations of academic integrity were found. The report contains the following comments. 1. It's unclear from the dissertation conclusions whether all research tasks formulated in the introduction have been completed. 2. The dissertation does not examine the operation of the proposed electric vehicle anti-slip system under emergency operating conditions of the traction induction motor, which may significantly affect the overall operational safety of the electric vehicle. 3. In my opinion, the author has not sufficiently substantiated the choice of direct torque controller, DTC, for the induction motor used in the computer model of the electric drive, particularly in the model shown in figure 4.12. 4. In my opinion, Chapter 5, particularly Section 5.2, is overloaded with well-known information on the fundamentals of neural network design. 5. In my opinion, the author has not paid sufficient attention to substantiating the use of the selected Norma L2 controller architecture. 6. The submitted materials don't make it clear whether the author considered the parameter sensitivity of the selected Norma L2 controller architecture. Can Can the proposed solution be used in vehicles with different masses and wheel size and under different weather conditions? 7. The dissertation doesn't consider additional training or complete retraining of the neural network controller, which may be required as electric vehicle components were during operation. 8. A functional diagram of the electric vehicle wheel slip prevention system shown in figure 5.1 contains a torque sensor. However, the dissertation provides insufficient information about this sensor. The technical implementation of the speed sensor is also not explained in sufficient detail. In my opinion, these comments are mainly advisory and don't diminish the scientific novelty or practical significance of the results. The dissertation complies with the requirements of the current legislation of Ukraine, and Liu Han deserves to be awarded the degree of Doctor of Philosophy in the fields of knowledge. 14. Electrical Engineering Specialty 141, Electric Energetics, Electrical Engineering, and Electromechanics. Thank you.
Thank you. The floor is given to the applicants to respond to the comments.
Okay. Answer 1. All tasks formulated in the introduction has been completed. Chapters 1, 2, 3 cover analysis the problem and substantiation of the traction system structure. Chapter 4 covers development of mathematical and computer models. Chapter 5 covers synthesis and model-based verification of the wheel slip preventing system. I agree that this relationship should have been present more clearly in the general conclusion. Answer 2. Emergency operating condition of the induction motor were outside the scope of this study. The controller was examined during normal operation of electrical drivers when wheel slip occurs. Because of reduced wheel load adhesion, the effect of electrical and mechanical motor fault requires a separate study. Answer 3. Direct torque control was selected because its rapid response to change the torque reference, which is important for stop wheel slip. However, in my dissertation did not include a detailed comparison of DTC with other induction motor control methods. Answer 4. I agreed. The sensory material in section 5.2 was primed to explain the neural network architecture and the training process concisely. However, it could be shortened without losing the main research result. Answer 5. Norma L2 was selected as architecture designed for non-linearly dynamic plans. It enabled it enables identification of the dynamic of the simulated electrical vehicle and the generation of control action based on speed mismatch. Parameter comparative selection among several narrow network architecture was not performed. Answer 6. The proposed solution is not universal without tuning. For a vehicle with different mass, wheel radius, transmission, or rate of load condition, the model parameter must be changed. The controller verified and narrow network retrained if necessary. A complete parameter sensitivity analysis was not performed in this study. Answer 7. Online fine-tuning or complete retraining during operation was not investigated. In this study, the controller was trained in advance using simulated data. Where compensation could be implemented through theoretical diagnostics and retraining with updated data, but this requires separate verification. Answer 8. The torque sense in the functional diagram represent requirement feedback signal, but its specific type and hardware implementation was not defined. Where angular speed can be measured with input, while linear speed can be estimated using accelerometer with integration and theoretical correction. Thank you.
Valery Konstantinovich, are satisfied with the applicant's answers?
Yes, I'm completely satisfied.
We shall now proceed to the discussion of the dissertation. The opponents have already spoken. Reviewer, please. The floor is given to reviewer, Doctor of Technical Science, Associate Professor Hart of the Department of Automation and Cybersecurity of Power System at NTU KPI, Metro Anatolich Gapon, please.
Thank you. Dear colleagues, I think that Luhan's dissertation addresses the relevant task of improving electric vehicle safety through traction electric drive control. I positively assess the integrated modeling of the electrical and mechanical part of the vehicle, the development of the wheel slip detection method, and the use of the NERMA L2 neural controller. In my opinion, the applicant provided substantive answers and correctly identified the limitations of the model-based verification. I believe that the work complies with established requirements, and the Luhan deserves to be awarded the degree of Doctor of Philosophy in specialty 141, Electrical Energetics, Electrical Engineering, and Electromechanics.
Thank you. The floor is given to the reviewer, candidate of Technical Science, Associate Professor of the Department of automatic electromechanical system at NCHUK HPI. Tatiana Yurievna Kunchenko, please.
Thank you. Dear members of Council, the work has an integrated structure and combines electric drive theory, mathematical modeling, and neural network control. The development mathematical and computer models of the electric vehicle, the wheel slip detection method, and the development of neural network control of the traction electric drive are of scientific significance. The question is raised, revised satisfaction answers. The comment made to not change my positive achievement of the dissertation. I support awarding Luhan the degree of Doctor Philosophy in specialty 141. Thank you.
Thank you. The chair of the one-time specialized academic council. I would also like to state main position. I have to now comments on the dissertation. Luhan's dissertation is aimed at solving the relevant scientific and applied task of proving electric vehicles wheel slip. Its results are based on electric drive theory and mathematical and computer modeling and are correctly characterized as the result of the modeling-based study. The work corresponds to specialty 141 electric engineering, energetics, electric engineering, and electromechanics, and has scientific novelty and practical significance. I consider that the dissertation meets the requirements of paragraph 6, 7, 8, and 9 of the procedure for awarding the degree of Doctor of Philosophy, and the Luhan deserved to be awarded the degree of Doctor of Philosophy in the field of knowledge for 14 electric engineering, specialty 141 electric and energetics, electric engineering, and electromechanics. Does one else wish to speak? No one. The floor is given to Luhan for his conclusion remarks. Please.
Thank you, Chair. Dear Chair, dear members of Council, and all those present, I sincerely thank my academic supervisor for their support, professional advice. I thank the reviewer and official opponents for their careful consideration of the work, their questions, their comments, which will help me continue my research. I thank the council member and the department staff participating in the defense. Thank you all. Thank you.
Thank you. Dear colleagues, we must hold an open vote on awarding Luhan the degree of Doctor of Philosophy. The voting will be conducted by a show of hands. Are there any other proposed? There are none. Who is in favor of awarding the degree Doctor of Philosophy? Please vote. Who is against? No one. Who abstains? No one. It answers the result of open vote in favor 5, against 0, abstentions 0. Are there any comments or questions? No. Based on the voting result and pursuant to paragraph 28 and 29 of the procedure of awarding the degree of Doctor of Philosophy and requiring the decision of the one-time specialized academic council of higher educational institution or research institution of awarding the degree of Doctor of Philosophy approved by a resolution of the Cabinet of Ministers of Ukraine number 44 dating January 12, 2022, the decision is considered positive. Are there any comments regarding the voting procedure? Now, based on the open vote, we consider Liu Han's dissertation implementation of intelligent control system to improve the scientific of electrical vehicles by means of the electrical drives to be a completed qualification academic works containing new scientific substantial results. The dissertation meets the requirements of paragraph 6, 7, 8, 9 of the procedure for awarding the degree of Doctor of Philosophy and revoking the decision of the one-time specialized academic council of the higher educational institution of the research institution of awarding the degree of Doctor of Philosophy approved by a resolution of the Cabinet of Ministers of Ukraine number 44 dated January 12, 2012 to as requirements for the paragraph of dissertations proved by order the Ministry of Education and Science of Ukraine number 40 dated January 12, 2007. Liu Han deserved to be awarded the degree of Doctor of Philosophy in specialty 141 electrical, energetic, electric engineering and electromechanics. I propose approving as voting result. Who is favor? Who against? No one. Who abstains? No one. Approved unanimously. Are there any comments or propose? None. The following draft decision of the one-time specialized academic council is therefore proposed. On 29 July 2026, the one-time specialized academic council DF 64.050.264 of National Technical University Kharkiv Polytechnic Institute adopted a decision to award Liu Han the degree of Doctor of Philosophy in the field of knowledge for electrical engineering on the basis of the public difference of the dissertation implementation of the intelligent control system to improve the safety of the electric vehicles by means of electrical drives in specialty 141 electric energetics, electric engineering, and electromechanics. On the base of the open voting results, the one-time specialized academic council DF64.050.264 awards Luhan the degree of Doctor of Philosophy in field of knowledge 14 electrical engineering, specialty 141 electric energetic, electric engineering, and electromechanics. Who is favor of this decision of one-time specialized academic council? Please vote. Who is against? No one. The decision is adopted unanimously. On behalf of council members, allow me to congratulate Luhan on the successful defense of the dissertation and we wish him first academic and professional success. On behalf declared the meeting of the one-time specialized academic council closed.